will our universe come to an end? Will it rip to shreds in a flash? Collapse on itself? Or will it slowly freeze to death? Scientists are imagining the unimaginable. And they're coming up with some wild ideas about how it's all going to end. This is the end of the universe. A battle is taking place in the farthest reaches of space. No one can see it, but scientists are certain that it's happening, and that the outcome is grim. The universe is going to end. It won't happen for billions of years, but there is no way out. Working out how it will end is the challenge of astrophysicists around the world. They're pointing high-tech equipment out toward the heavens to unlock the secrets of our fate. The possibilities are frightening. In one scenario, gravity pulls the universe back into itself, similar to air being let out of an inflated balloon. The universe goes back to its original size. This is the Big Crunch.
That'd be the end of the universe, and a big fireball, as all the matter collapses onto itself. That'd be pretty dramatic.
Then there's the Big Chill. The universe expands until the nuclear furnaces that power all the stars burn out. The universe grows cold and dies.
A second possibility is actually kind of sad. The universe will continue to expand forever, and it will just grow into an increasingly cold and lonely place as the expansion removes our nearest neighbors from us, and we just end up a single isolated community of stars and galaxies.
Then again, there could be a much more spectacular end in which everything is ripped to shreds, down to the last atom. Think of it like a balloon that is filled with too much air. It pops.
It's much more dramatic than the Big Chill, and just as fateful as the Big Crunch. The universe continues to expand, but at an ever-quickening pace. And in fact, the pace is so great that even the space-time fabric cannot hold the universe together.
However the end comes, it will be a dramatic conclusion. To understand how it all could end, scientists turn to how it began. The mystery starts to be solved here at Mount Wilson Observatory overlooking Pasadena, California. In 1929, while looking through what was then the world's largest telescope, Edwin Hubble makes a strange discovery. The universe is expanding.
Hubble's discovery led to a whole new picture of the universe, that it was a dynamic environment and that it evolved. It changed in time, and that's different from pictures that people had of cosmology previous to that.
Before Hubble, scientists said that the universe was static and unchanging. Hubble's discovery that the universe is expanding meant it had a starting point. A beginning.
That brought the idea forward that, hey, what if we ran the film backwards in time and found the point at which that began? And that was where the idea of a Big Bang came from.
The Big Bang, that fraction of a second when the universe and everything in it exploded into existence from a point smaller than an atom.
One common misconception about the Big Bang is that we can identify a point in space where the Big Bang occurred. But in fact, it's more appropriate to think of the Big Bang as a simultaneous creation everywhere in space, which is then continuing to expand to the present day.
If the universe has been expanding since the Big Bang, scientists must consider that it will stop expanding at some point. The question is, how? The most obvious answer involves gravity. What goes up must come down. Stars and galaxies and everything else might reverse direction. The universe would collapse in what some scientists call a big crunch.
Take the top and then see the other handle and just jerk them apart.
A model rocket offers clues to how the big crunch would work. The rocket is like the universe expanding into space out of the Big Bang. An initial bang allows the rocket to overcome the pull of gravity.
5, 4, 3, 2, 1.
The engine blast gets the rocket moving off its launch pad. It accelerates into the air and breaks free of gravity's pull, for the moment. It appears as it's climbing upward that it will never stop. But Earth's gravity won't allow this to go on forever. Eventually, when the fuel is exhausted, the rocket coasts about a meter higher, stops, and is pulled back to Earth. This is what would happen with a big crunch. The entire universe is essentially pulled back to its launch pad.
The universe itself has its own momentum, its own energy. It's moving outward. But eventually, there's a point where possibly the universe will stop that moving outward, just like the rocket that we saw, and have to fall back in upon itself and collapse again under the force of its own gravity.
In this scenario, the universe could return to its original state just before the Big Bang, setting the stage for a perpetual seesaw of creation and destruction. The Big Crunch theory moved to a scientific backburner. Cosmologists worked out that there must be some form of energy that keeps the universe from collapsing. The existence of such a force leads to new theories about what the universe is made of and how it might end. And evidence about how this might play out is found in some of the most powerful and mysterious phenomena in the cosmos: black holes. Predicting how the universe will end involves some of the most advanced technology known to man. On a remote volcano on the island of Hawaii, astronomers are monitoring a battle in space that is shaping the fate of the universe. At an elevation of nearly 4,300 meters, the Keck telescopes bring astronomers from all over the world nearer to space for a clearer view of the cosmos. They come here because the telescopes work best far away from city lights and as high as possible above the Earth's polluted air. Harsh conditions make it difficult to work here, but for scientists in pursuit of the great mysteries above, it's paradise.
So this is a remarkable location, but of course the air is very thin, it's extremely hard to work here, but these telescopes are amazingly powerful. But we're ambitious astronomers. We don't just stop looking at easy objects. We try hard to look at the very faintest objects so we can understand the extremities of the universe, the most distant objects that tell us about the universe when it was very young.
Here, astronomers like Richard Ellis are working on a problem that has been all-consuming for cosmologists since Edwin Hubble. They know the universe is expanding, but what they don't know is how fast. It will be difficult to predict exactly how the universe will end until they solve this mystery. The answers lie in the past.
An astronomer like myself uses a ground-based telescope as a time machine. We're looking back in time to study distant galaxies, seen as they were a long, long time ago.
Richard Ellis and scientists like them train their telescopes on light from the past. They're seeing things that validate long-standing theories about the cosmos by observing objects that technology has only recently been able to see. And what astronomers are finding is that one of Einstein's predictions in particular just might be responsible for the crushing end of the cosmos. Einstein said that there has to be more mass in the universe than we can actually see. He predicted that there would be patches of invisible supergravity from which not even light could escape. One of the distant galaxies that astronomers found revealed a powerful source of X-rays from something they could not see. It was in the constellation Cygnus and emitted no light. But something was there. Whatever was emitting these X-rays had a mass about 7 times that of the Earth's sun. There wasn't a name for it, so they called it a black hole. Black holes offer scientists an analogy to how the Big Crunch theory works. When certain stars run out of fuel, they collapse in on themselves into a smaller and far denser mass that attracts more and more matter, just like the Big Crunch. The gravitational pull is so powerful that anything that falls near a black hole will be forever trapped. Not even light can escape. It's a mind-boggling concept that something invisible is detectable and offers a view to our ultimate fate.
This black tarp represents space, and space is relatively flat, but when you put a massive object into space, it curves it. This is a penny, and notice how it comes into a really beautiful circular orbit. Basically, the black hole trapped it into an orbit around itself, and that orbit becomes very circular as it gets closer. And now the penny will eventually disappear, go inside a black hole. What if our universe eventually collapsed upon itself? What if eventually all of the matter in the universe were enough to gravitationally cause it to collapse into one huge black hole? Then at the end, you would end up with a big singularity. So that's one possible future of the universe, that we end up in a singularity. We came from one, we might go into one. And that's one way you can look at it on a big macroscopic scale. That black holes, in some ways, their physics is very similar to what started the universe. And so that may be how we end up.
Black holes exist in isolated areas throughout the cosmos. A black hole's gravitational pull is a scaled-down version of the force that could cause the universe to collapse. That force is dark matter, and dark matter is what scientists often call cosmic glue.
Hi, Matthew. So let's do some cosmology here. Dark matter attracts other objects via its gravitational attraction. It's a positive force. Dark energy, we don't really understand what it is, but it's a negative repulsing effect that pushes galaxies away from each other.
The whirlpool in Richard Ellis's demonstration represents the gravitational force of dark matter. The green dye coming out of the syringe shows how the stuff of the universe collapses under the force of dark matter.
The presence of dark matter acts as the focus for the gas in the universe, bringing structure together. This is how the Milky Way developed as the universe expanded. Little things merging into big things, the positive, constructive force of gravity. Now, if this was the only force in the universe would stop expanding at some point in the future, and eventually the universe would start collapsing. Gravity would eventually halt the expansion, bring it back together in a big crunch.
This dark matter is responsible for producing galaxies in a finite amount of time. If we had to rely on the gravity of atomic matter to produce galaxies, we wouldn't be anywhere, we wouldn't exist today to be able to ask these questions, because there's not enough time for gravity to have condensed the atomic matter that we know exists in the cosmos. So dark matter has to exist to help this process out and speed it up.
Yet the universe continues to expand and isn't showing any signs of collapsing. This suggests the opposing force of dark energy could be stronger than dark matter. But it will take scientific detective work to find out. They look to one of the most violent forces in the universe for clues.
We're studying exploding stars to try to understand if they can tell us the rate at which the universe is expanding.
These are explosions at the end of the lives of stars, not unlike our sun. The fuel that these stars have in their centers is spent. The star collapses, the outer part expands, and the star becomes something called a white dwarf.
White dwarf stars sometimes have other stars orbiting nearby, a companion star. A massive explosion could happen if the companion star's debris falls onto the white dwarf, causing a spectacular fireworks display in the cosmos. Scientists consider exploding stars, or supernovae, like in these images captured by the Hubble telescope, to be reliable telltales of how fast the universe expands. Their brief and bright explosions allow scientists to track the universe's expansion and give them a way to measure its speed.
Essentially, they are white dwarf stars that become nuclear bombs. They explode with a certain brightness and a certain length of time. It takes a certain amount of time for that brightness to dissipate. They are essentially standard candles. Any one of these will look the same no matter where it is in the universe.
Astronomers measure the distance and speed of these exploding stars by measuring the amount of red light they emit. The faster the star moves away from us, the redder its light appears.
When we study the spectrum of a supernova, we get indicators of its chemical composition. We understand the velocities as the supernova shell expands following the initial explosion. And so there's a lot of physics that we can study about the individual events.
The expansion rate of galaxies containing stars like supernovae can then be used to interpret how the rest of the universe is moving outward.
We know this because we can compare the velocities of galaxies with their distances.
These are the clues that lead astronomers to answer just how soon the universe will reverse direction and come back together in a big crunch. Or this information might lead to an entirely different conclusion. Dr. Ellis is looking at clues at the Keck Observatory in Hawaii. While the telescope is on the top of a huge volcano, he is in a viewing room on another part of the island.
Hey, emission lines, Johan.
Oh, you see it?
In the red side.
At the same time, Johan Reschar is at the California Institute of Technology in Pasadena, California, evaluating the light from a distant galaxy that the Keck telescope captured in Hawaii. He's looking to see if any of the known elements coming from the galaxy are in the red spectrum and moving farther away.
We can interpret that as a velocity, as how much the galaxy is moving away from us. We can really interpret how the entire universe is behaving, is expanding.
Interpreting redshift is the cornerstone of the quest to pin down the fate of the universe. Clearer pictures of the universe that have only been possible in recent years have led cosmologists to conclude that the red shift of distant galaxies is greater than previously predicted. This is startling. Not only is the universe expanding, it's speeding up. Nothing in the observable cosmos could account for an accelerating universe. And yet the data seems irrefutable. This has to mean that an invisible force is working against gravity. Cosmologists have come up with a name: dark energy.
So when the universe was young, gravity was the most dominant force. And so what we see here is galaxies as particles on the surface of the water bound together by gravity. And the point about 7 billion years ago, dark energy and gravity are pretty well in balance. But the universe continues to expand, the density goes down, and so dark energy starts to take over. And lo and behold, the universe starts to accelerate. So dark energy is now the dominant property of space.
So the universe started out with a certain amount of energy, and we know we're trying to understand how much energy there is, and we know the universe is expanding as it moves outward with time. We also know now that the universe's expansion is accelerating, and we don't know, is that acceleration going to slow down or not? We're still trying to understand that. So in understanding what's going to happen to the fate of the universe, we have to know how much energy is there, how much matter is there.
The history of the universe is really a battle between dark matter and dark energy. These two forces are in opposition, and so both the history of the universe and its ultimate fate is really the competition between these two forces.
The Big Crunch theory was a result of scientists interpreting that dark matter is the dominant force. But astronomers now suspect that dark energy might be much stronger. If so, the end could be dramatic and violent.
It pulls apart solar systems, it pulls apart stars, and eventually it grows so strong that it pulls apart matter itself, breaks bonds, pulls apart atoms, and reduces everything to fundamental particles, and that's the end of the universe.
The battle between dark matter, the force that holds the universe together, and dark energy, the force seeking to tear it apart, has set the universe on a path of destruction. If dark matter is the victor, the universe might collapse. If dark energy rules the cosmos, it could rip to shreds.
The expansion grows so strong that it tears up the entire universe.
It'll be a strange twist of fate. Dark energy, the force that propelled matter to form a magnificent universe, continues to push it outward and drives it to its demise. To find out if dark energy is in fact winning the battle, scientists will first need to know how fast the universe is actually expanding.
The most remarkable feature of the universe is that it's expanding. Every galaxy is moving away from every other galaxy. We can illustrate that with this balloon. As we expand it, we see that every dot drawn on this black balloon, like the night sky, is moving away from every other dot. But there is something else that we know about the universe, something else that we know about the expansion. That is that the expansion is getting faster. The universe is accelerating. The size of the universe is getting bigger at a faster and faster rate. We don't know exactly how fast it's accelerating, but if it's accelerating fast enough, then something really dramatic could happen. The universe could end up tearing itself apart in a big rip. This is perfect. This is great that you rigged this up. So this is a giant version of the demo that I do in class.
Dr. Robert Caldwell attempts an earthbound experiment to show how dark energy affects the acceleration of the universe. He uses a paintball gun mounted on a truck.
Yeah, and basically, I mean, we could adjust the angle in any way that you want it. What do you think about this?
I think down at the
down
ground,
a little bit more.
He sends the truck coasting down an incline. Earth's gravity pulls the vehicle downhill, which is similar to how dark energy propels the universe outward, causing it to expand. Gravity pulls the truck forward at an increasing speed. The gun fires paint at the ground at regular 1-second intervals. Caldwell measures the distance between the paint dots to calculate just how fast the truck was accelerating. He'll use the data from this experiment to see how gravity's force compares to dark energy's force in the cosmos.
We started thinking about the Big Rip when it was discovered that the expansion of the universe was accelerating. The degree of acceleration is not known, and it's the subject of a lot of effort by astronomers today to try and figure out exactly how fast the expansion is growing. What is the past evolution of the universe in detail, and if we can glean from that, what is the future evolution of the universe? It's not known exactly how fast it's accelerating. There's some evidence that the acceleration is beyond a certain threshold, and beyond that threshold, there's a runaway effect that could take place, and it would rip apart the universe.
Look.
Fantastic. I think we've got some good data.
Excellent. How do we measure this?
Great. Give you that end.
All right.
I'll take this.
5 feet 8.5 inches.
The point of the paintball experiment is to find parallels between the truck propelled by the invisible force of gravity and the accelerating universe.
I'm glad we got the long tape measure because it's really growing pretty fast, the interval.
Within a few measurements, the distance between the paint spots increases by nearly 7 times. If the truck were in space, at this rate, it would travel faster than 160 kilometers per hour within a minute, and over 1,600 kilometers per hour within 10 minutes.
They're getting big now.
The question for Robert Caldwell is whether the same kind of expansion and acceleration are happening on a cosmic scale.
This right here is the data that I took with Eric. The cumulative distance traveled by the car as a function of time. And that's beautiful. It's this nice parabolic shape. That's exactly what you expect for an accelerating body. Now over here I've got another calculation going on where I'm working out the acceleration of the universe.
Robert Caldwell's calculation shows that forces on Earth are similar to forces in space. This demonstration then gives a sense of the dramatic rate of expansion that appears to be happening in the cosmos.
By eye, it might be difficult to appreciate how good a fit it is, but I can tell you that the weight of the statistics indicates that an accelerating universe is a very good fit to this data.
If, like the truck, the universe is continually accelerating, then billions of years from now, the universe might tear itself apart.
All the distant stars and galaxies will be pulled away from each other. They'll be pulled away from us. But moreover, we won't have time to grow cold and lonely. It'll actually be pretty exciting and dramatic and violent. Stars are ripped apart, planets are ripped apart, and even atoms are torn apart before the universe ends. It wouldn't happen for at least 50 billion years, but still it's an interesting fate for the universe.
What would atoms ripping apart look like? Things like coffee cups are solid. Atoms join together to create something that will hold a cappuccino without leaking a single drop. Zoom in through the cup like sailing through the cosmos, past the molecules and into the atoms. The solid cup is nothing more than a fabric of atomic particles that formed a bond to become matter. If these particles were to move apart, the bonds that hold this cup together stop working. The atoms no longer support molecules. The connections between the minuscule particles dissolve. Matter in the form of this cup ceases to exist. It disintegrates, gone from existence. This is the dramatic end that Robert Caldwell foresees for the universe.
What you would see if you were standing on Earth or standing on some other planet that happened to still be around at that time, you would see something that looks like a wall of darkness approaching you. And as the wall of darkness approaches, stars would go out, galaxies would go out, and then eventually that wall of darkness would surround a planet. And then pretty soon, atoms themselves are torn apart, and that's it. Just the wall of darkness shrinks down to a point, and that's the end of the universe.
According to Robert Caldwell, that moment is still billions of years off, leaving plenty of time to refine their research.
In a way, this is like a detective story. We're trying to figure out what is the culprit, or who is the culprit responsible for the cosmic acceleration. We think we know its name. We call it dark energy, but we don't know the modus operandi. We don't know exactly how it works. And what's needed is more information about the physics behind the dark energy. We want to know exactly what it does and exactly what it's made out of. And in answering those questions, we'll be able to figure out exactly what is the fate of the universe.
The Big Rip is one theory. Cruising just above Earth's atmosphere and peering deep into space, The Hubble telescope provides scientists with clues to a less violent, but equally unavoidable end to the universe. Scientists now say the universe is expanding, and that depending on how fast it is accelerating, it might end in a big rip where everything tears apart. It's also possible that it will continue to expand, but at a slower rate. The universe wouldn't rip apart, but would become dark, cold, and lifeless.
If dark energy turns out to be constant, a constant property of space, and continues at the same rate that it is now, the universe will keep expanding forever, and it will be a very sad state. I think in the end, it just chills out. Everything cools down.
Evidence for the Big Chill and all of the theories for the end of the universe, in part, come from the Hubble Space Telescope. It has been orbiting Earth since 1990 and has an unobstructed view of the cosmos. The extraordinary images it beams back to Earth are amazing in their clarity and detail. And because of Hubble, scientists can make better predictions about how the universe will end.
So here is an example of a very deep field that was taken by the Hubble Space Telescope, which literally you point the space telescope at a single region in space. And if you looked at this from a typical ground-based image before Hubble was launched, first of all, it's literally almost size of a postage stamp. And so suddenly, the first Hubble deep field that was ever taken had 4,000 galaxies that looked just like the galaxies here, that were never visible before from the ground. A tremendous power. Each of these smudges in their own right is another galaxy. Each one of these galaxies contains about 100 billion stars.
Astronomers eagerly await all images from Hubble, each bringing them closer to solving the mystery about the fate of the universe.
Through image processing with computers and differencing frames taken on different nights, we can take out the other galaxies in the image, and we're left with just this blob. Looks like nothing to you, but that's supernova. And this is an object that could never have been discovered before Hubble Space Telescope was launched.
Hubble sees more than just stars and galaxies. It might just be onto one of the key ingredients of space, an invisible ingredient that could put the brakes on dark energy's effect and cause a big chill. That's dark matter. Scientists talk about dark matter as the substance that holds the universe together and could prevent a big rip. Evidence that dark matter exists is seen in some of Hubble's images of nearby galaxies. It sometimes appears as though other galaxies surround them. The other galaxies are not really there at all. Rather, they are reflections of more distant galaxies coming from behind. Astronomers suspect this optical illusion is dark matter, causing a weird distortion of light called gravitational lensing. The light from the more distant galaxies is literally bent by the curvature of space caused by stars and dark matter in its path. The more dark matter there is between Earth and the distant galaxy, the more the light will be bent and the greater the force to cause a big chill.
The gravitational lensing is a tremendous tool for the astronomer because we can measure the distortion in background galaxies and use it to trace the distribution of dark matter on various scales. We're looking at a distribution of idealized galaxies here on the sky, and the light from these distant galaxies is passing through clumps of dark matter. What you look at is not really what's happening. It's a bit like wearing spectacles and not knowing that you're wearing them.
And if you can tell how much that bending is occurring, you can map the dark matter, and you can also see, well, if there's dark matter there, is the universe around that dark matter behaving the way it should given the gravity or not?
Identifying which energy force dominates, dark matter or dark energy, will give scientists more confidence about whether a big chill or a big rip will be our fate. The best evidence shows dark energy as the driving force, but by how much? Solving this mystery depends on astronomers finding ways to measure how fast the universe is moving. On Earth, it's simple to determine how fast something moves. An airplane, for example, is relatively close. We can look at it and calculate its speed by estimating the distance it travels and timing how long it takes to get from one point to another. But a star's light can travel for millions or billions of years before it can be seen on Earth. By the time its light gets here, the star will be long gone, and it's too far away to gauge its speed or distance traveled with any certainty. The universe is expanding. Only scientists cannot give precise answers about how fast. The mystery moves closer to being solved by imaging the cosmos with greater precision.
You couldn't even observe the galaxies that are in this image before Hubble Space Telescope was launched. So the increase in our capability with technology recently has been astounding. It's enabled us to do things to chart the evolution of the universe in a way that we never could have imagined.
Clearer images from space make it easier to estimate the rate of expansion.
If the universe continues to expand with time, then ultimately all of the energy sources, the nuclear furnaces and stars, would run out and die, and the universe would actually get very cold, and there'd be something called a big chill.
In the big chill scenario, Earth could become a lonely, cold planet as the universe expands. Distances between stars grow so vast that they nearly disappear from view. Over time, they burn out. And eventually, the entire universe ends in a frozen state. These are ideas that sprang from the work of Einstein and Hubble. Only neither of them lived long enough to see the results.
Imagine what Edwin Hubble and Albert Einstein would think if they were alive today watching the progress in the subject. You know, Einstein thinking about the expanding universe as a natural solution of his equations, but puzzled, you know, that the universe didn't appear to be changing. Edwin Hubble, desperate to measure whether the universe was slowing down in its expansion. In fact, you know, they were both wrong. It's speeding up.
The time that Einstein developed the general theory, we didn't know that there were other galaxies outside of our own Milky Way galaxy, and we didn't know that the universe was expanding. And in fact, Einstein himself, despite the fact that his equations were screaming at him that the universe had to be evolving, didn't have enough confidence in that result to say the universe must be expanding or the universe must be contracting.
Still, his work led to the scientific breakthroughs that would identify dark matter and dark energy, the forces that could cause a big chill. This sphere demonstrates the principles behind a big chill. The marbles coming out of this sphere are like stars that were formed following the Big Bang. Dark energy propels the stars outward. Dark matter slows them down. In a big chill, the expansion would continue, but the nuclear fuel that causes the stars to burn will eventually run out. From Earth's perspective, the first thing to go would be sunlight. The sun dims as it exhausts its last bits of nuclear fuel. Earth would freeze and become lifeless. And billions of years after humans are gone, the cosmos expands out of view. A few newer stars might remain, but most would have long moved away. The furnace powering the universe burns out. The darkened universe continues to expand, a frozen and lifeless remnant of its once vibrant existence.
Eventually, if this keeps going, if nothing changes in the composition of this energy density, the universe will continue to expand forever. It's going to get colder and colder. And eventually, even our neighboring galaxies will be receding from us so fast that we won't be able to see them. So the universe is going to get cold and dark, and it will be a very lonely place.
Astronomers have much to learn about the influence of dark energy and dark matter. And much of the newest information is coming from this probe in deep space. It's sending back information that's helping scientists to interpret the history and the fate of the universe. The night sky, by all appearance, is a quiet and peaceful place. But in reality, there are forces that are driving it to an end. Big science moves astronomers closer to deciphering the universe's great mysteries, including its ultimate fate. The solution to the universe's riddle may well be hidden in this multicolored image. What's incredible is that it's a map of the early universe from the moment it was conceived. And even more fantastic, it reveals a great story that helps cosmologists predict how it will end. The machine that captured this is called WMAP, a NASA satellite that's working around the clock to chart the cosmos.
What we're looking at here is the edge of the visible universe. It's the light that WMAP measured, it's the remnant heat from the Big Bang, and this is literally the oldest light in the universe that we can see. This fossil relic from the early universe tells us a great deal about what the composition of matter was like, what the expansion rate was like, and really what the conditions were at the birth of our universe.
WMAP is one of the great astronomical breakthroughs of the 21st century. Nothing before it could give us such a clear image of the energy left over from the Big Bang. Energy that scientists call the cosmic microwave background. WMAP is measuring temperature differences in the cosmic microwave background, which may finally make it possible to predict which force will dominate the universe and how that force will bring the cosmos to its end.
The blue spots are regions in the microwave light that was produced by the Big Bang that are slightly colder than the average temperature, and the red spots are regions that are slightly hotter than the average.
Temperature differences revealed by WMAP tell scientists about the nature of the matter and energy that is contained within the universe. They're able to analyze the light patterns and find clues not only about the substance, but also the fate of the universe.
We only capture a tiny part of the electromagnetic spectrum with our eyes, and we have to go to much longer wavelengths. The same wavelengths that are used to heat water in a microwave oven are what we're measuring here with WMAP.
WMAP is so precise that it can detect differences in temperatures as small as 1/1000th of a degree. This sensitivity helps scientists to calculate the ratio of dark matter to dark energy, forces that will determine how the universe ends.
We assembled all those difference measurements and make a map of what the variations look like. And by turning up the contrast, we can basically subtract off this uniform glow from the Big Bang and look for variation.
It doesn't look like much until Gary Hinshaw adjusts the contrast. Then the WMAP image comes to life. Looking at WMAP imagery is in essence taking a journey back through space and time so that we might get some new ideas on the fate of the universe. Pulling away from the probe and following the path of the light it is collecting, we pass Mars, Jupiter, and Saturn, whose reflected light takes over an hour to reach Earth. Then, leaving the Milky Way, we pass Andromeda, the next nearest galaxy, whose light takes 2.3 million years to reach us. Which means we have traveled 2.3 million years back in time. And finally, we arrive back 13 billion years ago, at the beginning of visible light. Before that, superheated hydrogen gas is everywhere. WMAP can see this far back in history. It's confirming important facts about the universe and what's driving it to its demise. The final act for the universe becomes more easily predicted thanks to WMAP. Its information, combined with the work of astronomers, has led to some astounding discoveries concerning a rapidly expanding universe. Rapid expansion supports the dark energy theory and the possibility of a big chill or big rip.
We now know from all the data we've had in the last 10 years that there's, by a factor of 2 to 1, more dark energy than dark matter. So dark energy is the dominant constituent of energy in the universe.
The evidence seems clear. Dark energy is taking over and is leading astronomers into new thoughts about the beginning and end of the universe.
Before the discovery of dark energy, things were a lot simpler. If we could determine the amount of matter in the universe, then we could say something about its ultimate destiny.
Those simple days are gone, but the proof is adding up and supports the idea that the universe will continue to expand. But will it do so to oblivion?
We've made huge strides over the last century in learning something about the evolution of the universe and its expansion. But we've now raised more questions in some sense than we've been able to answer. And so I think the next decade is going to be even more exciting.
Astronomers have tons and tons of challenges that have been thrown our way by theorists, and we are rapidly trying to figure out how to answer all of these questions. And I think that's the exciting future, because if you can go out and really observe something, you're testing it. And that's what science is all about.
The battle between dark matter and dark energy is expected to go on for billions of years, and humans will be long gone from Earth when the final outcome occurs. But no pursuit has been more significant to science than understanding how the universe arrived, how it works, and how it will end.
It's a never-ending quest. It's driving astronomy. What are the answers to these profound questions? The constituents of the universe, the nature of dark matter, and perhaps the biggest mystery of all, what is the ultimate fate of the universe?
Lots of things going on, Michael, and we continue to get new reports every week.
Yeah, it sounds like lots of things going on now. With the volcano activity, the earthquakes, the weather phenomena, you know, everybody keeps talking about pole shift. I mean, is that something you see coming, or should we be worried about these wars even more?
That's what the Navy sees coming. That's why the Navy has been conducting classified briefings since 1979. In these classified briefings, Michael, and you and I have talked about this before, they advise their sailors that when they retire, they should consider relocating to the Arkansas, Missouri Ozarks to be away from these oceans, because the oceans will come out of their basins. There's only one phenomenon that we're aware of that can cause that to happen worldwide, and that would be a pole shift. Now, more localized events, say, for example, the east coast of North America, that could be caused by a different event. That would be a massive rock and dirt slide in the Canary Islands, which is another major concern for people on the east coast of North America. There's currently, as we speak, on September 13th, a massive swarm of earthquakes taking place in the Canary Islands that, by the way, the United States Geological Survey is blocking out. They're not publishing that swarm of earthquakes. So, yeah, really? a pole shift is a very clear and present danger, absolutely.
Yeah, because, you know, I've been checking into it, looking into it, and I get people who send me reports and email all the time, every day. And, you know, there's a lot of concern over the pickup in earthquakes and the volcanic activity. And, you know, I have people who are telling me they're getting visions that they should get off of the coast. And now we just had another asteroid that's passing by close to Earth. And, you know, is there any outside interference that could be helping along with this, or is this just an Earth cycle that's happening?
Well, it is an Earth cycle, and there is an outside influence. Both things are true. The outside influence, of course, is the 10th planet, also called NIBIRU, the destroyer wormwood. As it gets deeper into our solar system, it causes more severe problems with volcanism, seismic activity, bizarre, strange weather events. The Gulf Stream stopping was initially precipitated by these events. And the final thing that stopped the Gulf Stream, of course, was the British petroleum oil spill, which stopped a very fragile and very much at-risk Gulf Stream in June 12, 2010. So yes, the outside influence is the 10th planet interacting with our planet and the sun and all the other planets as well.
I see, and I've been getting reports from people as well about strange smells in California.
Right, sulfur dioxide. Right, the salt in the sea. The government's trying to convince people it's dead fish. Well, a dead fish smell may carry a couple of miles at the most, but it's not going to carry 125, 150 miles, which is what the reports are saying.
Amazing. All right, so what do you think all this is going to start coming to a head? I've been hearing November. What do you think?
Well, there's, as far as the Earth changes, I'm not going to make any predictions about a date. We'll see incremental increases in the number and severity of all these events. And when it comes to man-made events, we're looking at the third week of October as a possible time for a contrived economic collapse. The communists that support Hussein Obama are very concerned that he won't win an election, and they may contrive an economic collapse that would lead to martial law and a calling off of the election to make sure that their man stays in office.
Yeah, I've been a little concerned about that myself. Do you think they'll also bring this on by with more war in the Middle East?
Well, beginning day before yesterday, things really heated up dramatically in the Middle East, as we all know. Once again, certain people would like to see a war, and they apparently published this film knowing full well that once it got turned loose in the Middle East, it would drive these people absolutely bonkers crazy, because that's who they are. It's part of their religious belief to go bonkers crazy when somebody makes fun of Muhammad. So that's very predictable, and that's exactly what happened. When we're living the consequences of it now, the headlines on Drudge right now, Michael, are very disturbing, that the State Department had 48 hours notice before the embassy was attacked in Libya, and they did nothing. That's inexcusable. And once again, as we've known the past more than 30 years, the Marine Guards were unarmed. They had weapons but had no ammunition.
Wow. Now, some people think that was a setup, or, that maybe the United States set that up somehow just to have more excuses to go and maybe bomb more. What do you think?
Well, possible.
You think?
I mean, all these wars have been contrived going back to the Spanish-American War, so why not contrive one more on top of all the wars we've had since the 1890s with the Spanish-American War? The last time the U.S. military defended this country was the War of 1812. All these other wars have done nothing to defend the United States of America. They have enriched the bankers and caused a lot of death and misery, but none of these wars have defended the United States.
I would agree with you on that one, absolutely. And it's been all warmongering. I mean, all these wars in the Middle East are for their own personal agendas. I mean, there's no reason for us to be over there. I really don't believe Iran or Iraq was a threat, Syria or any of them. I think that they're picking on the little countries, trying to take out these leaders and put their puppets in.
Iran has a 1,000-year track record of not causing any harm to their neighbors. I mean, that's pretty commendable.
Yeah, it is.
There is a nuclear program in Iran, but it's not an Iranian nuclear program in Iran. It's a French, Chinese, and Russian nuclear program with French, Russian, and Chinese equipment, French, Russian, and Chinese technicians, and French, Russian, and Chinese technology and supplies. All three of those countries, by the way, are 3 of the 5 permanent members of the United Nations Security Council. And they could stop the French, Russian, and Chinese could stop the Iranian nuclear program in a heartbeat. Just order their people to get on planes and leave. And that'd be the end of it. But they haven't. And Russia, the last thing Russia and China wants is a bunch of crazy Iranian Muslims on their southern border with nuclear weapons. I mean, that's the last thing.
Yeah.
You know, seriously. You know.
Yeah.
So there's no evidence that the nuclear program in Iran is anything but the proper use of nuclear material and technology for peaceful purposes. There's no evidence of anything else. There's beliefs and fears that have no evidence, but that's all they are. It's beliefs and fears with no evidence behind them.
Right. That'd be like me fearing that my neighbor might come break in and kill me one night, so I better go over there and do it to him first. I mean,
all right, well,
there's no logic in that.
You know, that's a psychosis is all that is.
Yeah.
And what's being promoted about Iran is basically mass psychosis. You know, we just it's kind of ironic. We invaded Iraq because of the non-existent nuclear weapons program that Saddam Hussein did not have, and it was so humiliating to see Colin Powell, General Powell, presenting the fabricated evidence to the United Nations and the world and it was fabricated evidence of a non-existent nuclear program. That's why we went to war with that country. We went to war with Afghanistan because Osama bin Laden, there's no evidence connecting Osama bin Laden to anything to do with 9/11/01. But we went to war with that entire country because he allegedly was there. It turns out he wasn't even in the country. He was in Pakistan. Our ally, Pakistan. And the compound that Osama bin Laden was living in was 3 football fields distance, about 300 yards from the main gate of the Pakistani equivalent of West Point. Not exactly a remote mountain village.
No, not at all. So, you know, a lot more fabrication is what that is. I never thought that us killing Fred Flintstone was going to make us any safer. I never felt like he had anything to do with 9/11. There's a lot more to that story. I don't know if we'll ever get all the answers to it, but we know that that's been a good punching point, a nice fear monger that they've used to get people to say, "Oh yeah, the Patriot Act's great and the NDA bill is awesome." But, you know, yeah, they're now understanding what it really means. I mean, we're not really a free country anymore. People aren't understanding that.
Right, and
first.
You're right, and the intrusions into people's lives and their personal space, like what's going on with the TSA, setting up checkpoints now in bus stations. They set up a checkpoint at a Mitt Romney rally in the last 24 hours. Now after you get through the TSA checkpoint at the airport and you buy your bottle of water inside the secure area, they want to check it then. there was some lady, this happened just a few days ago, you may have seen the story, some lady bought a bottle of water inside the secure area of the airport. The TSA people demanded that she check it, that they test it. She refused. She drank the water, and they wouldn't let her on the plane because she drank the water rather than let them check it. And then there was a video of her, a recording of her confronting these people and she said, "You didn't let me on the plane because you don't like me, don't you? Didn't you?" And they basically said, "Yeah, that's right."
Yeah, and you know, it's TSA. It's gotten out of hand, and I was telling the listeners, I've said it a few times, that what a perfect job that would be for some pervert who just hasn't got a record yet, who hasn't been arrested yet. I mean, just go become TSA member, and you can pick and choose who you want to feel up and who you want to harass and torment. I think it's horrible.
I went through the TSA checkpoint in St. Louis about 6 weeks ago, and I was escorting my grandson to the gate. I wasn't flying. So I put my boots in the little bucket and all that, and this is my first time I was picked out to go to the naked body scanner. So I'm standing there. They say you got to put your arms up in the surrender position, the classic surrender position. So I do that, and then they say they ask me, "Are you wearing a chest brace?" I said, "No, I've got a double holster rig. I don't have a chest brace. I wear 2 holsters underneath my shirt." Well, that stopped everything, Michael. And the TSA guy calls over the supervisor and he whispers, "This man's wearing 2 holsters." And of course, I had no pistols. I left them in the car. And I said, "Would you come with me to the private screening room?" I said, "Sure, I'll come with you to the private screening room." And he brings another guy with him. And I had on a Western shirt with snaps instead of buttons. So I'd unsnap my shirt, take off the double holster rig, because I have a concealed carry permit, Michael, and I teach concealed carrying, of course, in Missouri. And I hand it to him, and he has his blue gloves on, and he checks out the holsters, and he hands it back to me and says, "Okay, you can go now." You know, and that's what they put people through. There's no rhyme or reason to it. Wearing holsters is not a prohibited item. It's just another piece of fabric, like any other piece of fabric. But it stopped the entire process and took up these 2 men's time for a good 10 minutes while they checked out my empty cloth holsters.
Yeah, it's amazing. I mean, I've heard stories about them. One old lady, a grandmother, they made her take off her diaper or something along those lines.
Yeah, the adult diaper she was wearing. Yeah, how humiliating.
Yeah.
How absolutely humiliating.
Yeah.
Live your whole life and be treated like that. But that's what we've come to. And the liberals in charge, the communists in charge in Washington, D.C., they just think it's so funny that us people out here, and us barefoot peasants, as I refer to myself and everybody else, that we put up with this. And of course, I know a number of people who absolutely refuse to fly commercial. I won't fly commercial unless I have absolutely no choice. I'm planning a trip right now, and I'll be driving 2 or 3 days, probably close to 3 days, to make my destination, just to avoid flying commercial.
And that's what I would do too. I've never been on an airplane yet, and now you could throw it out the window. Now I definitely won't. And they know this, and now they're starting to set up, like you said, at bus stations, and they want to start hitting the interstates as well, don't they?
There's talk about that. I'm not sure how they're going to pull that off. If they start stopping people on the interstate highway, there's going to be some problems, I can guarantee it, depending on what part of the country it is. And they may get away with it in Massachusetts, but you try that stuff in Kentucky or Tennessee or Texas, Oklahoma, that could cause some really serious problems. Wyoming.
No, I agree with you.
You know, you don't pull over these cowboys for no reason at all. I mean, you just don't do that. That is not a very wise thing to do.
No, and that's just it. I mean, you got to wonder, when does it come to a point when people have absolutely had enough? I mean, even the ones who have been at the wheel, sleeping at the wheel, they've got to be waking up to this. And if they haven't, they will. And, when is enough going to be enough? That's what I wonder.
Well, that's true. I mean, you get some guy out there who's maybe put in a double shift. He's dirt dog tired. He wants to get home, and he's being pulled over for no reason at all. That's a very dangerous situation, especially depending on what his mental attitude is. Say he put a double shift in a factory where it's 105 degrees inside the factory, where they have a very hot process going on, and he's got a bad attitude before he gets pulled over. You're setting yourself up. There's nothing more dangerous, Michael, than a man who has no fear and knows that he's right.
Oh, you're absolutely right. And I could think of a few nights when I was driving home from work when, being harassed for no reason wouldn't have been a good idea.
Right.
So
right.
I totally understand. John, let me ask you this before we hit our break. Getting back to the Middle East just a little bit here. Israel seems to be really pushing hard to attack Iran. You think they're controlling all this?
It's possible. It's possible that they are. We're hearing lots of rumors. I haven't seen any evidence yet. There's, of course, this film that's enraging these people. This being promoted as having been funded by Israelis or American Jews, I should say, which I don't know if that's true or not. But if it is, that's certainly fuel to the fire. What they're doing behind the scenes, I don't know. The Mossad is regarded within the intelligence community as being a very small and very good intelligence service. So what they're doing behind the scenes, it's difficult to say, Michael.
Absolutely. All right, John, hang on with me.
Thank you.
Are you on Monday through Friday?
Monday through Friday, 7 to 8 a.m. Central Time, 8 to 9 Eastern on Republic Broadcasting.
Yeah.
Right.
Well, I know you've got a lot of people who follow you because, I get emails all the time from a couple of guys who are constantly sending me links. They're keeping track of everything John Moore says. So.
Yeah, there are. It's about 10 to 15,000 people a day.
Hey, that's great. That's really great. And
with modern technology, we can actually track them because the majority of people don't listen live; they listen on YouTube.
Right. Yeah, you're right. The one show that you and I have done has gotten over 200,000 views already. So
amazing.
Yeah.
250,000 people. That's amazing.
It is. It is amazing. And if we had to rely on, say, network radio like AM or FM, I mean, these messages that we get would never get out, would they?
No, they would not. That wouldn't be allowed. I've been on Fox News Nationwide twice talking about terrorism, and when it came time, I was working with this young female producer in New York, and she says, well, John, what do you want to do our next show on? So I said, let's do a show on the feel-good, make-believe security at these airports. So she says, I'll talk to my boss and get back with you. So she calls me back the next day, and she says, John, we can't do that. It's too scary.
Yeah.
And that's all it is. Feel-good, make-believe security. There was one of these pilots, one of these commercial pilots. He was authorized to carry a firearm, which I was one of the behind-the-scenes advisors on that. But he went public with what's common knowledge in airport security, and that's the people that work out there on the flight line. They don't go through security checkpoints. They have a magnetic card that they swipe and go through a side door by themselves without going through security at all. And when he pointed that out, the TSA and the government got mad at him, and they took his authority to carry his pistol on the plane away from him.
Wow.
And all he was doing was pointing out, it's a well-known fact that the flight line workers don't go through the security checkpoints like the pilots and the crew do.
Yeah, and those scanners, I don't care what they say, you get people who are flying constantly all week long, and they have to keep going through those scanners. I mean, once is too many times, but, hundreds of times a month maybe. Not good. No,
the radiation is not healthy and is not a good thing. And frequent flyers have an issue with that. And, of course, the crews, they're already getting radiated because of the high altitudes they fly. They pick up a big dose of radiation in that manner. And so that, I don't know, but I would suspect there's a very high likelihood that these people would be getting a larger incidence of cancers.
Right. Now, as we move closer to November and December, and, we know all the things that could happen. We know the things that are happening. Why don't we tell people a little bit of what they should do maybe to prepare themselves? And again, folks, we're not fear-mongering you. We're just simply talking about the things that are happening right now.
Absolutely.
What should people be concentrating on?
Well, the first and most important thing, Michael, is for everybody to get their spiritual house in order. That's the most important thing anybody can do for themselves. Moving on from there, we hear a lot about, get your water stored up in food, but you need skills. And the two skills that will be in biggest demand and shortest supply are emergency medical treatment skills and the skills of a ham radio operator. Whether your group is 4 or 5 people or 400 or 500 people, those two skills will be in biggest demand and shortest supply. In my community where I live, we started a preparedness program for the community, working with the mayor, the chief of police, the fire chief. One of the first things we did, Michael, was identify everybody in the community who had any kind of medical skills at all. The nurses, EMTs, paramedics, doctors, dentists, medical technicians, dental hygienists, anyone and everyone with any kind of medical-related skill. We identified them, we approached them, and we asked them if they would agree to help out during a crisis, and without exception, everyone did. We also identified all the ham radio operators in our community and approached them as well, and they were all agreeable to helping out in a crisis. So work on getting those two skills, getting the emergency medical treatment skills and get ham radio skills. Obviously and clearly, you should have a good quality gravity feed water filter, something that does not take electricity, or 40 psi pressure, to make things happen. You should have a stock of food. I recommend 2 years' worth. At least get a month's worth. The government's only suggesting, I think, 2 weeks' worth. A 1 month supply is a good start, and once you get that basic 1 month supply, just build onto it and add on to it as finances allow. If you have any medical conditions that require pharmaceutical products, a stockpile of those pharmaceutical products would be an excellent idea. And if you have to pay for it out of your pocket, well, then go ahead and do it. I know that insurance is not going to pay for more medications than what you need on a monthly basis, but bite the bullet and get what you need. If you need pharmaceutical products to stay alive, then get a several-month supply. Whatever it takes to do that, you should do that. An event like an electromagnetic pulse, Michael, would shut down this country and bring it to its knees. And in 4 to 6 weeks, every person who requires a pharmaceutical product to stay alive, almost all of them are going to be dead. 8% of the adults in this country have diabetes. And I don't know how many of them require insulin to stay alive. I'm sure it's a substantial percentage of those. All those people, with very few exceptions, will all be dead in 4 to 6 weeks. And there's other pharmaceutical products, like, for example, pharmaceutical products that are anti-rejection medicines. If you have a kidney transplant, any kind of organ transplant, heart transplant, these people have to take special medications to keep the body from rejecting that transplanted organ. If you're cut off from access to those supplies, you're going to die. So it's a tough wake-up call, Michael, but people need to be aware of this. They need to take action, and they need to do it now while they can, while we have what appears to be the luxury of time. The luxury of time could go away in 5 weeks. If this economic collapse becomes a reality, it could get real tough real quick. So a word to the wise is to pay heed, get prepared while they can, and do what they can within their own abilities, whether it's everybody has financial and physical limitations, but work within those limitations and do what you can, Michael.
That's right. And I got a question from one of the chat rooms. They asked, when would this Planet X, when would it make its closest pass-by to Earth? Many are reporting that they could see it from the southern hemisphere. And I imagine if it could be seen, then it must be on its way. So
right. Well, chances are some of those reports are true. There's a Brazilian astronomer, I can't tell you his name as I don't recall off the top of my head, but a Brazilian astronomer who's connected to a government observatory who's gone public with saying that he's seeing it right now. Brazil's kind of at odds with the New World Order, so it doesn't surprise me too much that one of their government-sponsored astronomers would be going public like that. Having a date is not and should not change anything. And I use the example, Michael, of the Navy veterans. The Navy veterans weren't even told about Planet X. They were told the oceans would come out of their basins, and they were told that when they retire, that they should set up a self-sufficient lifestyle. The place you want to be, Michael, is where you don't need to think about or worry about any specific date. There's no good result from that. That only can cause heartache and ulcers. The place you want to be is prepared, where no matter what happens, you've done as much as humanly possible to deal with it. And you don't have to worry about a date, anguish over a date, think about a date. It's simply not something you need to do because you've got your preparation squared away. That's a good place to be emotionally and spiritually, Michael.
Yeah, I agree with you. Definitely should be prepared in some way. And I tell people all the time, even if you don't believe that there's going to be a Planet X or even a World War III or any of that, you should still be prepared because the way the weather's going and the earthquakes and stuff, you never know when your area is going to be marked for something like that. So you want to be prepared anyways.
Absolutely. Absolutely. As my friend Professor McCanny said to response to a lady, she wanted him to tell her when the closest passage of Planet X would be. And his response was, well, ma'am, once I give you this date, what are you going to do? Buy another case of tuna fish? I mean, seriously. What would you do that you should not? What are you going to do that you're not doing anyway? Once you understand and comprehend that this is real, like all the Navy veterans understand that it's real, then you take action and you change your lifestyle to be in comportment with your understanding, as opposed to at odds with what you understand. If you're not doing everything you can be doing, your actions are at odds with your beliefs. That's not a good place to be, Michael.
No, it's absolutely not. And what about the sun? A lot of activity with the sun. Is this because it's being affected?
You're right. The Department of Homeland Security, I'm glad you mentioned that. I haven't talked about this for a while. The Department of Homeland Security is very concerned that a major solar event could take place in the next 5 to 6 months, resulting in a solar flare that would be the natural equivalent of electromagnetic pulse attack, what might be called a Carrington event. They're very concerned that another Carrington event would happen. The last time this happened was 1859, just before the American Civil War, and that solar flare was so powerful that it started fires in telegraph offices. We had no nationwide power grid or any power grid at all, but we did have a nationwide telegraph service. Those telegraph wires, Michael, acted as antenna to pick up that energy and direct it into the telegraph offices, and it did start fires. So the Homeland Security is very concerned that this could happen in the next 6 months, and people should be aware of this. There's an excellent book at my website, Michael, that people can download and read at no charge. It's written by a commission of scientists, engineers and scientists appointed by the government to look into the effects of electromagnetic pulse attack. And the first 60 pages is the most important. It's about 189 pages or so. But that first 60 pages is the most critical. It will tell you what you need to know, what you need to get prepared for. It will, if it would happen, either a Carrington event from the sun or a man-made weapon shot off in space, it would bring this country to its knees, and you and I would never live long enough, Michael, to see this country become what we call normal now. It simply would not happen in our lifetimes. It would be devastating, absolutely devastating, and bring this country to its knees.
Absolutely, and if the New World Order got their way, they would probably round guys like yourself and myself up first and make sure that we were put away. So, they don't like anybody getting woken up. They don't like this information getting out. And, they've got a lot of, I call them agents that they put out here on the Internet that put out this information to try to make, guys like yourself look crazy, when we talk about these things.
That's well known. That's well known and well documented that there's disinformation, trolls out there trolling, and disinformation websites, and absolutely.
Yeah, for sure. So now, in the last, I don't know, we got about another 15 minutes or so. What are you looking at right now? I mean, what is in your radar right now? What type of things are you making sure you're keeping up with as far as your audience goes and such?
Right.
Your concerns.
We're paying real careful attention to what's going on with the Middle East. We're watching these Russian Spetsnaz, special forces troops that are in this country. We've now confirmed that the Russian Special Forces are violating the protocols that they agreed to for communications, and they're using encrypted communications to communicate with Mother Russia, and they agreed before they came here that they would not do that. That's very serious stuff, very serious. The numbers vary wildly from hundreds of Russian spetsnaz to thousands. I don't know that the numbers matter very much. 500 or 600 of these men could cause great problems, huge problems for our country if they put their mind to it. We're watching these flu viruses. There's about 4 flu viruses right now that appear to be biological weapons that are loose in this country. They may be demanding people get immunizations, which, of course, I'm not going to get. They've announced now that quantitative easing number 3, QE3, is about to get underway. That's one of the things we're looking for as a precursor to a contrived economic collapse. That could spiral out of control real quick. It'll appear to be a spontaneous event when, in fact, it's a controlled and contrived event. And we're looking, if that would happen, we're looking for that to be happening the 3rd week of October. So it's a list of things that we're paying attention to and trading information on, my confidential sources in the government and Department of Homeland Security and the military. And we get this information, we compare notes, we verify and vet the information to the best of our ability before we go public with it. The stuff we don't go public with is very scary, and if it can't be confirmed, we simply don't talk about it publicly, Michael.
Absolutely, and and that's one of the things about Planet X that a lot of people have had a problem with is the not being able to absolutely confirm it. There's a lot of evidence that points towards it, and then there's a lot of stuff that points towards maybe something else going on, like HAARP. So it's really hard to determine when there is earthquakes and such. What could be causing that? And, I'm one of the ones that pulled towards maybe a little of both, the cycle that we're going through and HAARP. I think HAARP helps out.
Well, HAARP can do some things. People give HAARP more credit than it's due. HAARP can do some things some of the time in terms of manipulating weather. It can't manipulate all weather all the time. It's the world's most powerful radio frequency transmitter, and it can be direct that energy to pretty much any place they want. What it does is heat up the atmosphere. And it can, in fact, manipulate some weather some of the time. That's certainly a provable fact. I don't believe it can cause earthquakes. I've seen no evidence of it. I don't believe it can create a volcano. HAARP gets blamed or given credit for things that there's no evidence that it can do.
Yeah, absolutely. I hear a lot of things. I've heard about the earthquakes and so on, and I'm not sure. I guess, anything's possible. I can't say it's true or not true, but I do know that they do use HAARP, and other countries have it as well, and they have these little weather wars, it seems.
Oh, yeah. Well, weather is a powerful tool. If you can manipulate weather, you've got a lot of power. Russia's version of HAARP is not nearly as large as ours. When Russia built their own, we doubled our size, and I guess we wanted to have the biggest and best. So.
Yeah. What else is new, right?
I know that's just the American way, right? And I wasn't aware of anybody but us in Russia having HAARP type devices. I wouldn't be surprised if China has one of their own. England or Germany or France may have one. So, yeah, it can accomplish a lot of things, and I guess it could do some good things. It could bring rain, perhaps, to an area that needs rain. It probably has that capability also.
Well, they're slacking off then, because we've had a lot of drought in this country. The farmland has been affected terribly. And, there's quite a few out there who are suggesting we're going to have food crises soon.
Well, the food crisis in this country is going to be dramatic price increases, which will cause people to cut back on their discretionary spending as far as middle-class families. The truly poor, they're going to be hurt by this. There's no doubt about that. And these third world countries is going to lead to malnourishment and opportunistic diseases that take advantage of malnourished people. So it's going to be a lot of human misery because of these droughts and the dramatic increases in food prices.
But do you think that these droughts and different things that we're going through right now? Do you think that this is part of the plan? World domination.
I think they're making use of it. The Gulf Stream having stopped 2 years ago, June 12, 2010, is what's affecting the jet stream, and the jet stream, of course, is what's causing the drought. So they certainly incorporate anything that they can into their pre-existing plans to take advantage of it. And I think they're certainly doing that.
Okay, and I guess last but not least, John, chemtrails. I'm sure that you hear a lot about chemtrails. I know.
Oh, I get the emails, same emails you do, and it's a tough topic to address with any real closure. There's just tons and tons of speculation about what they're spraying and why they're spraying it. I tend to try to stay away from that topic because it's a bottomless pit of speculation is what it is, Michael, with no resolution.
Understandable.
Bottomless pit of speculation with no resolution.
Well, and I agree to a sense, I guess, but one thing's for sure, it's happening. That I know. I see it every day.
It's definitely happening. There's no doubt about that. It's an observable, provable phenomenon. But I've yet to see evidence that I would regard as clear and convincing as to the two questions: what they're spraying and why they're spraying it.
That's right. See, I'll agree with you there. And some people think they have the answers. I think it's a combination of reasons that they're doing it. I think one of them is to control the food. Maybe another is to, killing off live vegetation, and then you get these Monsanto seeds. And, hey, we've got the aluminum-resistant seeds, so buy from us. I think that could be one of the reasons. But hopefully we'll find out. Yeah. I hope we find out before it's too late, John. And
I hope we do. I know if Monsanto can make a buck off of it, they will. Oh,
yeah, absolutely. John, if there's any information you'd like to get out there before we close out, I want to thank you especially for jumping on with me on such short notice tonight.
Well, no problem, Michael. I've been a guest on your show a number of times. It's always fun. It's late for me. I go to bed at 9 and get up at 4:45. So,
oh, wow.
But it's fun to be with you. My show will be on Republic Broadcasting tomorrow morning at 0700 Central Time, and I invite everybody to listen.
All right, great. We've got you linked up over at LateNightInTheMidlands.com. John, keep up the great work that you do.
Thank you, Michael. Have a good evening. Appreciate it.
Thank you. You too. Good night. All right, everybody. That's John Moore, and we've got him linked up over on LateNightInTheMidlands.com.